always about the order of operations, always. You gotta do what's in the parentheses first. So in the parentheses, you simplify each individual radical. And then we're going to simplify these, and we want to see what we can actually combine together. Subtraction, think about it ahead of time. You know you're going to distribute the negative, but you want to simplify first. Work the problem from left to right. Work the problem from left to right. And I don't care what your calculators can do. Some calculators, you might learn how to punch the right buttons, you might get the right answer. But if your work is not backed up what you have as your final answer, you're not going to get full credit. There are 14 questions on the test, they're 10 points apiece. If you have the right answer, but the work does not connect to that right answer, you might get 2 out of 10. So in here, you have a getaway car of a 2. 96. That is equal to 2 and 48. You can go 2 times 48. Then we have a 2, and you have a, how about a 3 times 16? Because that's a 2, that's a 3, and then you have a 4 times 4. So the getaway car is the 2. Breaking out of that square root of 96, you have a pair of 4, so 1 breaks out. And staying inside is 2 times 3, a square root of 6. This is 2 times 4 square root 6. And the getaway car here is a minus 5. Minus 5 times. Now, first thing you want to break out here is poke out the I, square root of the negative. So you're going to poke out the I. 45. Well, I'd go 9 and 5. So there's a 3 times a 3 and a 5 that's going to stay in square root j. So you have a 3i and a 5 back in square root j. Now, because this is the first parentheses and you're subtracting from it, this one, you don't necessarily have to bring down the bigger parentheses because there's no sign change in front of it. There's no minus here. It's just this term minus that term. So you don't necessarily need to maintain the bigger parentheses around it, but you need to when you do this one, because it's subtracting that whole final inside. It's one tiny problem at a time. It looks menacing when you look at it as one bigger problem, but all we did was this tiny little piece, simplify square root 96. So we have a 2 on the outside, there's my 4 square root 6. Then we move on to the next part, one tiny little bit at a time. I'll bring down to negative 5, and then simplify the square root of negative 45. One tiny little part at a time. And since that's what we're doing right now, simplifying the square roots, keep that going. Because you're going to go straight across, bring it right down below. From left to right. Still working that one tiny little part at a time, because that way you don't change gears. Minus what's in here. So I'm going to keep that in parentheses so I don't forget to distribute. This getaway car is a 4. 4 times. Now here's what I talked about last week. If I'm going to combine any like terms, this is not imaginary because it's not a square root of the negative. So if I'm going to be able to add this with anything over here, it's going to have to add with the 4 square root 6. I'm going to have a like radical that's a square root 6. That's what I'm hoping for. That way I can combine this one with this one. So I'm hoping that I can get a square root 6 when I simplify it. So that is 4 times 6, and you got a 2 times 2, and then you got a 2 times 3. So the getaway card at the 4, 2 escapes. 2 times 3 doesn't get to escape. So the 2 times 3 goes back in square root jail as a 6. So sure enough, it has a square root 6 in it. So these will be like terms when I distribute the negative and combine like terms. So it's like a little foreshadowing about what I'm going to be able to combine, because I simplified this one first. And then getaway card there is a 3, so plus 3. And then times, simplify square root negative 80, so they're going to poke out the I. Poke out the I. And if I'm going to simplify that square root negative 80, I'm going to want it to be something like an I square root 5. Because this is the only term with an I in it, I square root 5. So if I have another I square root 5, I can combine these together. Well, 80 ends in a 0, so I can factor with a 5. This is 16 times 5, which is a 4 times a 4 and a 5. So 4 will escape, so I get 4i with a 5 left in square root j. So it is an I square root 5, just like this one. So I have an idea of what I'm looking for. So again, it's a huge problem, but it's made up of smaller little questions at a time. One tiny question, simplify that one. Yeah, simplify, don't forget the parentheses. Simplify square root 24, simplify square root negative 80, bring down the getaway. Don't be in a hurry. And now you simplify 2 times 4 square root 6, and that is equal to 2 times 4 is 8 square root 6. Negative 5 times 3i square root 5. Negative 5 times 3, that's negative 15i square root 5. I'm still not ready to distribute the negative because I haven't simplified the inside. So it's still minus parentheses 4 times 2, that is 8 square root 6. Square root 6. And then positive 3 times 4i square root 5, that's a positive 12i square root 5. So now 8 square root 6 minus 15i square root 5. Now I can distribute the negative. Minus a positive 8 square root 6 is now negative 8 square root 6. Minus 12i square root 5 is now a negative 12i square root 5. Now we just combine like terms. We have 8 square root 6 and a negative 8 square root 6. So positive 8 square root 6, take away 8 square root 6, they cancel out and make 0. Yes.
So when you're getting the number for the negative 80, does it have to be a big number? You can't do like an 8 and 10?
You can do an 8, you can do whatever you want. You will still get 4i square root 5. Because that's the only thing you can get when you break it down completely. Okay. I chose 5 because this ended up with a 5. So I used this as my clue as to what I should use over there. Okay. And if I chose 5, it was 16 and 5. And the good news is 16 is a perfect square.
Mhm.
So it went straight to 4 times 4. Okay. So those make a 0. And then I have, it's a negative 15i squared 5 and a negative 12i squared 5. So negative 15 of these I root 5s and a negative 12 of these I root 5s adds up to a negative 27 of those I square root 5s. And again, if you have an I and a square root, put the I before the square root. You said that way it's not going to look like it's underneath the square root. There's no confusion that way. That's all there's left. That's what it equals. It's like it's a really hard, really messy, a lot of step problem, but it really isn't. It was one tiny piece. Forget about the rest of it. Just 2 times whatever that's going to be. And then leave it, just that, right now you're in simplified square root mode. I'm going to simplify the square roots over and over and over and over again. That's what I'm going to focus on. Because if I keep going down, you're going to forget to do something down the line. You're going to leave something out. So you want to go from left to right and make sure you're taking care of every one of those and bring it all the way down and then do the next step straight across. Because otherwise something gets left off. Okay. When you multiply it on number 2, because that's now multiplication, simplify what's inside first. Order of operations, simplify the parentheses. So this parentheses, 2 times square root 5. Well, square root 5 doesn't simplify. It's 2 square root 5. Minus the square root of 81. So you're going to poke out the I. What's the square root of 81? It's just 9. So this is 2 square root 5 minus 9i. Okay. Then we have times 4 square root 5 does not simplify because it's a 4 and square root 5, nothing's going to break out. So that stays 4 square root 5. And we have a plus. And then square root negative 81 is going to be the same as that. You're going to poke out the I. Square root of the negative, you poke out the I. We get a square root of 81, so that's a 9. So 9i. So it's 2 square root 5 minus 9i times 4 square root 5 plus 9. So now we're going to multiply it together, which is just distribute. We're going to distribute the terms. Or if you want to use the word FOIL. So I'm going to write it out. I'm not going to do the multiplication. I'm going to write out and then I'll do the multiplication. So it's this one, the first term times the first term. So I'm going to write it out. 2 square root 5 times that 4 square root 5. Always with the sign. 2 square root 5 times a positive 9i squared root 5. So positive times a positive, that's going to be a positive. 2 square root 5 times a 9i. I'm just distributing. I haven't done the multiplication, just distributing. And then I'm going to distribute negative 9i, so it's a negative times a positive, so it's gonna be a negative 9i times the 4 squared 5. And last times last, a negative times a positive, that's gonna be a negative. And we have 9i times 9i. Now, can you, or could you have skipped a few of those steps or this step? A little bit, yeah. I don't mind. But if I do it right now, people are gonna go, well, like, where'd that come from? That's why I don't. When I multiply this right here, this, and if I would have skipped it when I wrote it out, I would have gone straight to this is equal to 4. If I would have just hit it first time first. But here's where that's coming from. 2 square root 5 times 4 square root 5. I can rearrange it. This is 2 times the square root 5 times a 4 times the square root 5. I can rearrange the term. So this is 2 times 4 times square root 5 times square root 5. So 2 times 4 is 8. Square root 5 times square root 5 is, you could look at it this way. Square root 5 times square root 5. It's either the square root of 25, which is a 5, okay? Or you could say it's the square root of 5 squared because there's 2 of them. And if you square the square root, it undoes the square root and you just get a 5. If I multiply a square root times itself, it undoes the square root. And I just get whatever's inside. So square root 5 times square root 5 is just 5. 8 times 5, this is a 40. So this times this, for the sake of going a little bit slower, is 8 times 5, which is 40. Okay. 2 times 4 is 8. Square root 5 times square root 5 is 5. Okay. And then I have the plus. The 2 times the 9 is 18. Square root 5 is staying in jail, and there's an I. So I have an I and a square root of 5. The only thing I can multiply is the 2 and the 9. I can't multiply into the square root, and I can't really do anything with the I except put it here. 2 square root 5 times 9 times I. So all I can do is rearrange it. 2 times 9 times I, and the square root of 5 left. 2 times 9, 18. So that minus 9i 4 square root of 5. So 9 times 4, that's 36 with an I and a square root of 5. Minus 9 times I times 4 times square root of 5. I can rearrange the I and the 4, so that's minus 9 times 4, and then I, and then square root of 5. So 9 times 4 is where the 36 is coming from. We've done that last part already. But again, you have to be careful about this, especially about the sign. This is minus 9 times 9 is 81. I times I is I to the second, I squared. You never leave a power of I except I to the first. Every power of I will reduce to something else, either an I to the first or a real number. Remember the rules. I to the first is just I. I squared is what? -1. I to the third equals -I, and I to the fourth equals +1. You gotta know your pattern. Gotta know your pattern of i's, pattern of I, power of I. So this is -81 times I squared is -1. So this ends up being down here plus 81. Simplify what's inside. Can't do anything with 2/3. Tiny pieces at a time. Minus, simplify square root -81, that's a 9. Can't simplify 4/3. Plus, simplify -81, that's a 9. Then we distribute. And all I did was actually write down what the multiplication is gonna be, so all I did was distribute, so I didn't actually multiply yet. One tiny piece at a time, where I actually didn't do any work really except distribute. Then I did this one tiny problem. Multiply these two together, I get 8 times 5. All right, I'd go a little bit further, that's 4. And then it's a plus. Multiply these together, 2 times 9, that's an 18. I have an I and a square root 5. Then I have a minus. Multiply these two together. 9 times 4 is 36. I have an I and a square root 5. And then I gotta be real careful when I multiply these two together. It's minus 9 times 9. Again, small problem. Everything else has been done. 9 times 9 is 81. I times I squared. Minus 81 times -1 plus 81. Do I expect to see this step right here? Yes. You can't just go from here to there. I'm gonna show this right here. I times I is I squared. Otherwise, I'm gonna go, well, how in the heck did you get this? Or it has to justify your answer. So my two like terms that I have so far is a 40 plus an 81. 40 plus 81 is 121. And then I have 18 I squared 5, a -36 I squared 5. So positive 18 of these I squared root 5, take away 36 of these I squared root 5. So they're like terms. 18 of them, take away 36 of them is -18 of those I square root 5s. Say it again, order of operations. Simplify what's inside before you square it. So this is equal to that 2. Getaway car is a 3. Simplify the square root of -16. So we're gonna poke out the I. What's the square root of 16? 4. It's a 4. And the whole thing is still squared. Before you square this, simplify what's inside. That is 2 plus 12i squared. If you want to use the special product, the whole A plus B addition squared, where you square the first term. Then you multiply A and B together, but it's double in the middle. And then you square the last term. You would put 2 squared is 4. 2 times 12 is 24, so that's 24i. Then you got to double it. So you have a 48i. And then you square the last term. So 12i squared would be 144 I squared. You still have to simplify that I squared to 48i. 144 times -1. That's minus 144 there. 4 take away 144 is negative 140 plus 48i. And if you notice, I keep putting the real number first because that's the way a complex number is written in its standard form. The real number, then the imaginary part. So if you want to use a special product, that's how you do it. Or you can just write it out. It's 2 plus 12i times another 2 plus 12i. 2 times 2 is 4. 2 times 12, 2 times 12i is 24i. Then we distribute the second term, 12i times 2. So positive and a positive is a positive, 12i times 2. That's another 24i. And then a positive times a positive, that's a plus. 12i times 12i. So 12 times 12 is 144. I times I is I squared. So you have this 4. 24i plus 24i is 48i. And then right here, you got 144. I squared is a -1, so it ends up being minus 144. And you now combine those two. So you get a negative 140 plus 48 times I. Either way. But it's about simplifying before you square it. Problem on the test gonna look like number 4 right there. Simplify 1 plus I over 3 plus I. You can't have radicals in the denominator, which means you can't have an I down there either. So we have to multiply, since it's a binomial, 2 terms, by the conjugate. What is the conjugate of 3 plus I? 3 minus I. It's the same 2 terms, you just change the sign. If this was minus, that would be plus. If you multiply the denominator by a 3 minus I, you got to multiply the numerator by a 3 minus I. Next, you got to distribute. Here we go. 1 times 3, we get a 3. 1 times negative I, that's a negative I. So we're done with the 1. Now we distribute the positive I. 1i times 3, that's a positive 3i. Real careful here. Positive I times negative I. So it's going to be a negative I times I which is an I squared. That's the numerator. 1 times 3, 1 times negative I times 3, positive I times negative I is negative I squared. In the denominator, we have 3 times 3. 3 times 3, that's a 9. We have positive 3 times negative I, that's a negative 3I. Then we have positive I times 3, that's a positive 3I. And then positive times the negative, that's going to be a negative. I times I is an I squared. The purpose, again, think about why we're doing what we're doing, to undo the I in the denominator. The numerator, we got that 3. Negative I plus 3I, what's that equal? What's negative I plus 3I? Oh, 2I. Positive 2I. And then this right here becomes minus a negative 1 because that's I squared is negative 1. If I subtract negative 1, it becomes what? Minus negative 1 becomes plus 1. Becomes plus 1. Okay. Down below, we have that 9. We have that 9. The whole purpose is to undo the I down here. Look what happens. Negative 3I plus 3I adds up to 0. No more I there. And then you have this minus I squared is negative 1. So what happens down here? You get plus 1. So we end up with, we got 3 plus 1. That equals 4. And a positive 2I. All over 9 plus 1 is 10. And if you leave it like this, at its 10 points, I would say minus 2 because you have to simplify. It's not simplified. And if all you do is go like this, my final answer is going to be 2 plus I over 5, but you don't show me how you got it. I'm still going to take off 2 because I'm going to say, how did you get that? Where's the work? So you got to show me one of 2 ways. You either show me that you did it with factoring, or you just split it into separate fractions. Do the splits or factor. So we're at 4 plus 2I over 10. If we factor, you have a 4, a 2, and a 10. They're all divisible by what? A 2. So we're going to factor out a 2. So that means we're going to have 2 times, and this is what I'm looking for. If I factor out 2, I'm dividing by 2. So 4, take out the 2, I have a 2 left over. When I factor it out, I'm dividing that by a 2. And when I factor a 2 out of this, I'm dividing by 2, so I have a plus I on the inside. 2 plus I. 2 times 2 plus I is what this is. Over 10 is 2 times 5. So that now reduces. I can now see what's reducing, and there's my final answer. 2 plus I all over 5. That's how you show it with factor. Factor, then reduce. Or do the splits. Split it up into 2 separate fractions. we can rewrite this as 4/10 plus 2i/10. And reduce the fractions individually, separately. This one is 2 times 2 over 2 times 5. So now when I reduce the 4/10, I get 2/5 plus this is 2 times 1 over 2 times 5. So when I reduce this, I get 1 times I over 5. So I can leave it as I over 5. I can leave it as 1/5 I. I don't want to leave 1 times I over 5 because 1 times I is just I. So I can use 2 over 5 plus 1/5 I, or 2 over 5 plus I over 5. Separate it into separate fractions, reduce each one individually. Just like you were solving for slope and y-intercept. You divide each one by whatever's in front of y. If I'm solving for y, I divide each one individually by the 4. Separate the fraction instead of dividing the whole thing and trying to factor. But you certainly just don't start crossing things off because that's not true. All right, that last example is it's on the review sheet as an example of bonus. So I'm giving you an example of that kind of bonus right now. Um, 4i cubed to the third minus 3i to the 12th, the whole thing to the 4th, and then plus 10 times I to the 521. So inside here, I'm going to go ahead and raise each one to the third. This is your rules of exponents. If you have a product to a power, A times B to a power of M, then each factor is raised to that power. Not to mention, if you have a power to a power, you're going to multiply the exponents. So what's going to happen right here? 4 is going to get raised to the third. I to the third is going to get raised to the third. So what we're going to end up with is 4 is going to get raised to the third, and this I cubed to the third, that's going to be an I to the 9th. Okay. Then we have minus. We're going to get a 3 to the 4th. I to the 12th to the 4th, so power to a power, that's going to be I to the 48. And since I have to simplify my bigger powers of I, here, I'm just going to bring this one down and I'll simplify this at the same time. So plus 10 times I to the 521. Now, here's the rule. Here's our pattern for i's. I to the first is I. I squared, we get -1. I to the third is negative I to the fourth is 1. And so the pattern repeats. I to the fifth is I to the sixth is -1, I to the seventh is negative I to the eighth is 1. So when we did this 2 weeks ago, you take the exponent that you have, you divide by 4, and the remainder is your new exponent. So if I had an I to the 103, I take the 103, I divide by 4. 4 goes into 103, 25 times even, I get 100. With a remainder of 3. The remainder is my new exponent. I to the 103 is the same as I to the third. I can rewrite this as an I to the third, and I to the third is -1. Sorry, negative I. Negative I. That's how you simplify. 4 to the third is 64. I to the 9. Well, 4 goes into 9 how many times? Twice. What's the remainder? What? We get a remainder of 1. So this is the same as I to the first. I'm just going to leave it like that. I'll come back and finish. Minus 3 to the fourth. 3 to the fourth is 81. I to the 48. So we go 4 into 48 how many times?
Mhm.
12 times 4 is 48. So what's the remainder? 0. Remainder is 0. Now, wait a second. I don't, oh yeah, I do. You see, if it goes in exactly 4 times, that would mean you have a remainder of 0, and everything to the 0 power is always 1, because that's rule of exponent number 7. Everybody to the 0 power is 1. Even I to the 0 is 1, as long as it doesn't equal to 0. So, and if I have a remainder of 0, that's a 1. This is an I to the 0. That's a remainder. It'll be a 1. Then plus 10 times 521. So 4 into 521. Well, now I'm not sure. 4 goes into 5 one time. So in the hundredth place, I have a 4. A 400. So then we subtract. 121. In the 10th place, 4 goes into 12 3 times. So I have a 12. 120. And then we subtract. And all I have is left is a 1. So 4 can't go in the ones place. I have 0 because it can't go into one place. So 4 goes into 521 130 times with a remainder of 1.
Right.
1. So this is 10 times I to the first. So 64, I to the first is just I. So don't leave I to the first. Don't leave I to the first there. This is just 64 I. I to the 0 is just 1. This is minus 81 times. This is just minus 81. And then 10 times I to the first, that's just 10I. And when we write this in standard form, the real number goes first, negative 81. And then you have 64I plus 10I, and that adds up to 74. Example of the first 4 test questions. Okay, example of one of the bonus questions. At 10 o'clock, we're going to finish up chapter 4 with the solving quadratic formula examples. Start with examples of, refreshing what we did on Wednesday with solving by factoring, square root method, and completing the square root. What we're going to do with. Quizzes are due at 10.